Okay, we're told a student wants to investigate the effects of real versus substitute egg on his favorite brownie recipe. 10 of his friends have come up with a consensus for the ranking of each of 8 batches on a scale from 1 to 10, and that has been recorded. 4 of the batches were made with real eggs, 4 with substitute eggs. The judges tasted the brownies in random order. I guess what is important for you to understand on this problem, because I think it's a little bit strange the way he has it set up, but the 10 friends come up with a consensus ranking. So you don't have 80 total outcomes, you actually only have 8, because the 10 friends decide on a ranking for each of the 8 batches. And so that's why your N here, your big N, is 8, and we have 2 different treatments, either real eggs or substitute eggs. And so N minus K there is going to be 6, because it was the 8 minus 2. And of course the eggs, the treatments, is the degrees of freedom for the treatments is K minus 1. Since there's only 2 treatments, it's going to be 2 minus 1, which is just 1. So it's a little bit funky, this problem, I think, the way they have it set up. It says, what are the null and the alternative hypotheses? Now when you're doing an F-test, of course the null and alternative is that the null is that they're equal, and the means are equal, and the alternative is that they are not equal. So that would be B. Now it says, what do you conclude from the ANOVA table? Use a level of significance of alpha equals 0.05. So if we look at our ANOVA table, we have 0.0014 as the p-value. That is less than 0.05, so it's very unlikely that the null hypothesis is true, and so we will reject the null hypothesis and say that they do have a different mean score. Okay, and then they actually want you to do a pooled, a 2-sample pooled t-test of the difference. And we haven't done this before, but you can click on View an Example and see the formula for it. But just to be nice, I went ahead and wrote, I just looked at View Example also and just wrote a little Excel spreadsheet that had that formula in it. So all you have to do is input your data information here. Now you're going to be using these numbers, the mean score and the standard deviation. So in this case it's 6.76 and it's 0.653 is the standard deviation. Now there's 4 in real eggs, and then there's going to be 4 in the substitute egg. So for the mean is 4.64, and then the standard deviation is 0.39, and again that's going to be 4, and then it's going to do all these calculations for you, and it gives you a p-value of 0.0014. Oh, the N again was that there were 8 total results, and the K was the number of treatments, which is 2, which gives us degrees of freedom of 6, and that's what we use in order to get the p-value. You use 2 times the right tail distribution there. So you get 0.0014 as our answer, which is a small p-value, which would you would reject the null hypothesis. So you do get the same conclusion if you had done a pooled t-test. Now it asks you to compare the square of the t-statistic to the F ratio, which is what I did right here. I just took my t-stat and I squared it. I get 31.07575, 31.0711. That's pretty close. So I would say that they're pretty much the same. So it's just kind of interesting. When you just are testing too, you can just do a t-test. Okay.